Greetings, fabulous math students, from Mrs. Marcellus. In this lesson, we will compare unit rates. Today's learning objective is students will find and compare unit rates and use unit rates to solve problems. There is no new vocabulary to record for this lesson. Let's go to our first example. Fred's car can travel 115 miles on 5 gallons of gas. Ginger's car can travel 126 miles on 6 gallons of gas. Whose car gets better gas mileage? We can solve this problem by finding and comparing unit rates. Let's start with Fred's car. First, we will write the rate that's given of 115 miles on 5 gallons of gas. Next, we will convert this into a unit rate. In a unit rate, we must have a denominator of 1, or, in this case, the amount of miles Fred can drive on 1 gallon of gas. To find the unit rate, we will divide both the numerator and denominator by 5. Or you can think of this simply as dividing the top number divided by the bottom number. Either way, you will get the same answer. When we divide by 5, we find that the gas mileage for Fred's car is 23 miles per gallon. Next, we will do the same for Ginger's car. We will start with the given rate of 126 miles on 6 gallons of gas. Next, we will have to divide by 6 to get a denominator of 1, or 1 gallon. 126 divided by 6 equals 21 miles per gallon. Next, we compare the two unit rates. Fred's car gets 23 miles per gallon, while Ginger's car gets 21 miles per gallon. Therefore, Fred's car gets better gas mileage with 23 miles per gallon. In our next problem, a new park had 510 visitors in the first 30 hours it was open. There were 960 visitors in the next 60 hours after that. Which is the greater number of visitors per hour? Again, we can solve by comparing the unit rates or the number of visitors per hour. We'll start with the first rate that's given of 510 visitors in the first 30 hours. To find the unit rate, we will divide by 30, and we learn that there are 17 visitors per hour. Next, we will compare this to the rate of 960 visitors in 60 hours. We will find the unit rate by dividing by 60 and learn that this is 16 visitors per hour. We can see from comparing the two unit rates, 17 visitors per hour versus 16 visitors per hour, that there were more visitors per hour in the first 30 hours the park was open. Comparing unit rates is a great way to figure out when something is a better bargain or deal, or which is the lowest cost if you are comparison shopping. In this problem, Pizza Palace is offering two specials. The first is $27 for 4 large pizzas. The second is $32 for 5 large pizzas. Which is the better deal? We can compare these two specials by figuring out which has the better or lower cost per pizza. We will start with the first special, which is $27 for 4 pizzas. Then we can find the unit rate, which will give us the price for 1 pizza. To get the unit rate, we'll divide $27 by 4 pizzas and find that it is $6.75 for 1 pizza. Now let's look at the second deal. We will start with $32 for 5 pizzas, and to find the price for 1 pizza, we will divide the $32 by 5. In this deal, the price is $6.40 for 1 pizza. When you're comparing the unit prices and we're looking for the better deal, we want the one that is less. In this case, it would be less expensive per pizza to buy 5 pizzas for $32. The better deal is $32 for 5 pizzas. However, you also have to consider your need. If you really don't need 5 pizzas and one of them's going to waste, it might be a better choice to buy the 4 pizzas for $27. Let's do more comparison shopping. The price for 1 dozen eggs is $1.80. The price for 18 eggs is $2.88. Which is the better buy? To determine which is the better buy, let's compare the unit price, or the price for 1 egg. We'll start with the rate of $1.80 for 12 eggs. 12 eggs equals 1 dozen. We will then divide $1.80 by 12 and find that it is 15 cents for 1 egg. We will do the same for $2.88 for 18 eggs. We will divide the $2.88 by 18 and find that the price is 16 cents per egg. Comparing only the price, we find that 1 dozen eggs for $1.80 is the better buy. Each egg is less expensive than the eggs in the box of 18 eggs. In this problem, we compared the unit price, or the price per egg, but we also could reverse this and look at this problem a different way. We could flip the price and the amount of eggs and find out how many eggs we could get for $1. We could start with the rate of 12 eggs for $1.80. To get the number of eggs for $1, we would divide 12 by $1.80, and we would find that we get 6.6 repeating, or approximately 6 6/10 eggs for $1. We can do the same with the 18 eggs for $2.88. To find the number of eggs per dollar, we would divide 18 by $2.88. The result is 6.25 eggs for $1. Next, we'll compare the number of eggs we can get for $1. In this case, we're looking at more eggs per dollar as being the better buy. The box of 12 eggs for $1.80 is still the better buy because you get more eggs per dollar than you do in the box of 18 eggs for $2.88. This concludes our lesson on comparing unit rates.